we go. Here we go. Welcome back. Today we're gonna be trying out a AMC 12. It's that time of year again, you know? So we're gonna do a practice AMC 12 or like a past test, and then we're gonna check our scores against the real cutoff and see how we do. Alright, let's get it. You already know where to go for this. AOPS AMC 12 practice tests. AMC 12 problems and solutions. Let's just pick a random one. They used to be much easier and then they get harder every year, so I did not take the AMC 12 last year, so we will do those. Also I'm gonna time myself. There's a time limit. In addition to timing myself, I'll be recording my answers on a new document so we can check over them later. Oh shit. And I also got my little brother with me. Say hi.
Hello.
Okay, he's gonna be trying to do these questions with me.
I am very genius.
W mans, bro. W mans, big brain mans. So there we go.
What's his scratch pad?
I'm just gonna be hitting out like 1, 2, 3. You know. All right, let's go. Let's go. Hold on, let me get the timer as well. AMC 12A, 12B, let's just do 12A, why not? Okay, we will now be attempting the problems. How much time do we get? This is a 25 question multiple choice test. Each question is followed by answers marked A, B, C, D, E. Only one of these is correct. You will receive 6 points for each correct answer, 2.5 for each problem left unanswered. So, okay. You have 75 minutes. Actually, not stopwatch. I need a timer. Here we go. It's gonna be a long ass video. But okay, whatever. 75 minutes, and then I guess we can start now. Alright, let's go. 3, 2, 1. I'll say it with me, bro.
Oh yeah.
3,
Three,
2,
two,
1. Okay, we're good. Let's go. First question.
you started?
What is the value of 2112 minus 2012 squared over 169? Well, this seems like it's a square. First of all, we know that. 169 squared is equal to 13 squared. I guess you just have to know that. And what's 2112 minus 2012? Let me calculate this on my iPad. It's exactly equal to 100. So 100 squared, or sorry, 100 over 13 squared is going to be 10 squared over 13 squared is just, I did something wrong. No, it is 100 squared, my bad. It's just 100 over 13 in parentheses squared. That doesn't make sense. What did I do wrong? Oh, it's not 2012, it's 2021. Recalculate. Recalculate.
Man failed already.
Hey, don't say that, bro. We still got
Oh
time.
yeah. He's just using his mind in a different way.
Okay, we got 91 squared over 13 squared. That looks better because we know that 91 is equal to 13 times 13 times 7. You're right. Oh, that's why I got a helper today.
Yes, I am very smart.
Oh, he's right. 7 squared, and we know what 7 squared is. Hey, yo. 1C. That worked. Alright, let's go next. Problem 2. Mr. Lopez has a choice of 2 routes to get to work. Route A is 6 miles long and its average speed along this route is 30 miles per hour. Route B, 5 miles. And the average. Oh, I'm on the wrong question. My bad. My bad. I'm tripping today.
Mm.
Question two. Mankara has a 4x6 index card. If she shortens the length of one side of this card by 1 inch, the card would have an area of 18 square inches. What would the area of this card be in square inches if she shortens the length of the other side by 1 inch? So a 4x6 has an area of what?
24.
24. So to shorten one side by 1 inch, I can either take away 6 or 4 from 24. Which one would give me 18?
Uh,
Take away.
what? Oh, wait, what? Oh,
Okay, I would take away 6, right?
yeah.
Okay, so instead we're going to change it to a 3x6.
Genius.
So we're changing the short side. What would the area of the card be if she shortens the other length instead? So we changed it to a 3x6. Instead, we want to change it to a 4x5. What's the area?
20.
Okay, let work. 2e. 2e. Well, we can't be taking too long for these first questions, though. Problem three. Mr. Lopez has a choice of two routes to get to work. Route A is 6 miles long. Average speed is 30 miles per hour. Route B is 5 miles. Average speed is 40 miles per hour, except in a 1/2 mile stretch in a school zone where his average speed is 20. So we can actually express um, the second route, Route B, um, as two different roads. I guess you can say that. One road is 4.5 miles long, and he travels 40 miles per hour. Yes, good so far. And then the second part is 1/2 miles, but instead, how fast does he travel?
20 miles per
20
hour.
miles per hour. By how many minutes is Route B quicker than Route A? Okay. Well, we're just finding time. And do you know the formula for time or distance, I guess?
Oh,
Distance equals what times what?
uh, time times rate.
Okay, well, you can say speed times time, but yeah, you're right. Distance equals rate times time, or speed times time. So time is equal to what?
Uh, mm, oh,
Distance over speed.
yeah, exactly.
Okay, so for the first one, we got 6 miles is our distance, and our speed is 30. So what's our time?
What?
For Route A, we've got 6 miles of road. That's our distance, and our speed is 30. So what's our time?
Uh, 6 divided by 30.
Yep, 6 miles divided by 30 miles per hour, which gives us 1/5 hours, or 0.2 hours for Route A. Now let's find Route B. We're going to have to do this as two different parts. We can call these B1 and B2. B2 equals this distance of what's the distance?
4.5 miles?
Yeah, I'm going to express that as a mixed number as 9/2 over the speed, which is 40. So what's 9/2 over 40? It's
Oh,
just 9/80.
yeah, exactly.
And then what's the second part? We've got B2, TB2 equals 1/2 over 20 equals 1/40. Good.
Mm-hmm.
Equals 2/80. Now we can add these two times for a total of 11/80 hours. Cool. Somehow that doesn't seem right. That is a bogus answer. Wait, what the heck? What did I do wrong? Let's see. distance equals or time equals distance over speed. So for the 1/2 mile, you would do 1/2 divided by that. And for this one, you would do 5 miles. No, sorry. 4.5 miles divided by 40. Ooh. Yeah, let's just have faith. We have 0.2 or 1/5 minus. Oh no, route B is quicker. Ooh. So we have 11/80 minus 1/5. That's 55 minus 80/80 times 5. That's already wrong. Okay, we did something wrong. What did we do wrong? 6 divided by 30. That's 1/5. Yeah?
Me?
Okay, now we have 4.5 divided by 40. That's 9/80.
Uh, hmm.
And we have 1/2 divided by 20, so that's 1/40,
Yeah, wait.
which is 2/80. And if you add that, that's 11/80. Oh, but this is supposed to be less time, so we're going to take 1/5 minus this. Yeah. Okay, I think we're getting somewhere. 1/5 minus 11/80. This is equal to 80 minus 55/80 times 5 equals, what's 80 minus 55?
25.
25 over 80. What's 80?
80.
Can I say 80 is 13 times 5?
Yeah.
Okay, 13 times 5 times 5
Wait, 13 times 5?
equals 80.
Uh,
That's not right, huh?
yeah, that is not right.
What's 80 divided by 5?
Uh,
16.
yeah.
16 times 5 times 5 on the bottom. Cancel the top and the bottom, and we get 1/16 minutes. Oh, this is in hours, but we need to change hours to minutes. I see. That's why it didn't make sense. So do you know how to change hours to minutes?
You just times it by 6 beforehand.
Yeah, because there's 60 minutes in an hour. And then what do we get? 60/16 equals, what's 60 divided by 4? 115/4.
Yeah.
And what's that? 3 and 3/4.
B B 啊，
So
我看
we
到你那
get
个 email 哈，
3B.
你有没有看到你的 email？
Huh?
不是，
The 6-digit number, this number, A, is prime for only one digit A. What is A?
Wait, what?
So this number is going to be prime for only one digit A. 20210A is going to be prime. So we know that, let's see what we know. A is probably not 0, because that would let us divide it by 10. A is not 2, because that would let us divide by 2.
Couldn't you just like do every answer?
And we know it's not going to be 4A either.
Oh.
Yeah, so we're going to test all those. All the even numbers, we're just going to not use those. So what we're left with is 1, 3, 5, 7, or 9. Now it's time to use our divisibility rules. If A equals 1, what's the sum of the digits? 2 plus 2 plus 1 plus 1. That's 6. That's divisible by 3. So we can't have A equals 1. What about 3? 2 plus 2 plus 1 plus 3. That's 8. So we don't know about that one yet. What about 5? 2 plus 2 plus 1 plus 5. 10? But we
Yeah.
can't have 5 because that's obviously divisible by 5. So let's cancel that one. How about 7?
Uh,
2 plus 2 plus 1 plus 7 is
12.
12. That's divisible by 3. And finally we have 9. What's 2 plus 2 plus 14. So our only options now are A equals 3 or A equals 9. Sadly, those are both answer choices. So we can go fast and just guess and try 50-50 right here, but let's actually get some practice and think about this. How do we know if it's divisible by 3 or 9? Well, or not divisible. It's prime for 3 or 9. Um, this is a tough one.
Uh,
If the number ends in 9, um, it's not going to be divisible by 3, yeah? Because we just showed it's 2 plus 2 plus 1 plus 9 is 14. So I'm thinking it's only going to be able to be divisible by 7, right?
yeah.
So let's try it. 202,109 divided by 7 is what? Oh man, long division.
0 to
I put a 2 there, 14, 6 down, 2,
um 8.
8, 56, 6, 1, 8.
61.
Did I get that
Oh,
wrong?
wait. Oh, my bad.
Okay, and then what's next? 7, 49, 19, and that's, I did, oh no, that's 19, yeah. 2, 14, and we get a remainder of 5, so it is not divisible by 7. Now let's try to see if 202,103 is divisible by 7, because we just showed that 202,109 is not divisible by 7. Same process, 2, 14, 6, 2, 50, what, 56, 8, 6, 1. Actually, I probably could just use my work from above, but I don't know why I'm doing all this. 5, 0, 7, 4, 9, 1, 3. That's also not divisible by 7. Ay, ay, ay. What's a number? What order are we doing wrong here? Well, we know that if it ends in a 3 or 9, then it's obviously not divisible by what? The even numbers?
Yeah.
Not 1, not 5. And we just showed that it's not divisible by 3
Yeah.
because they don't add up to 3 or something times 3, right?
Yeah.
Because 2 plus 2 plus 1 plus 3 is 10, and 2 plus 2 plus 1 plus 9 is 14. And it's not divisible by 9 either because it doesn't add to something that's a multiple of 9. So the only option that was left is 7. But they're they're both not divisible by 7.
Huh.
That's a problem. That's a big problem. Yeah, let's come back to 14 if we have more time. I don't think we have enough time to waste here on these questions. 3 or 9. Not sure which one yet. Okay, let's take a look at the next ones. Actually, did we try 1 yet for this one? 2 plus 2 plus 1 plus 1. Oh, that's 6. Okay, yeah, we can't do that.
How about 7?
2 plus 2 plus 1 plus 7 is 12, so yeah, we can't do that. And it's not 5, definitely. So it's either 3 or 9, but we couldn't find the answer for some reason. What is it, my division skills? Okay, whatever. Elmo, the emu, takes 44 equal strides to walk between consecutive telephone poles on a rural road. The Oscar, the ostrich, can cover in 12 equal leaps. Okay. And the 41st pole along this road is exactly 1 mile from the first pole. So we're saying the first pole. Okay, I get it. So what this question is saying is telephone poles are evenly spaced, yeah?
Yeah.
And between the first pole and the 41st pole, how many like gaps do you have to walk? How many um telephone poles do you have to hit? You can think about it like if I started from 0 and I went to 40, how many is that?
Wait, but
So we're gonna have to go 40 things, yeah? So 40 pole lengths, I'll just say that, or distances between the poles, pole distances,
Mhm.
or you can even say pole gaps, is equal to exactly 1580 feet, yeah?
Yeah.
So how many feet in one pole
Uh,
distance?
55,280 divided by 40.
Yeah, and this is gonna be
0, 1.
1, 2, 8, 3, 1, 20, 80. That gives us 132 feet between a pole length. Yeah?
Mm-hmm.
Elmer the emu takes 44 equal strides to walk 132. Yeah? 132 feet.
Yeah.
So, how long is one of his strides?
132 divided by 44.
What does that give us?
I don't know, buddy.
Oh,
0,
3?
3.
Yeah, 3. 3 feet. That's Elmer. And how much is Oscar? 132 divided by 12. That's 11, right?
Yeah.
11 feet. What's 11 minus 3?
8.
Okay, so light work. 5B.
I understand how that happened, definitely.
Problem 6. As shown in the figure below. Okay, this is geometry.
Uh-oh. Actually.
Point E lies in the opposite half plane determined by line CD. That's this one. From a point A. So that CDE is equal to 110 degrees. Okay. Point F lies on AD so that DE equals DF and ABCD is a square. What is the degree measure of AFE? So they're asking about AFE, this angle here. So I'm thinking we can find AFE if we find the angle that's supplementary to it, or angle DFE first. And they give us FD or DF equals DE, so we know this triangle is an isosceles triangle.
Yes.
So let's do this. I don't know why they told us it's a square. I don't think that was necessary. F E D, and we got 110 here. So we know, oh, I know why it's a square. Because what does this angle have to be here if this is a square?
90?
Yeah, 90, because square. And we know that in a circle there's 360.
Yeah.
So what does angle FDE have to be?
360 minus
Minus
1. Oh, I mean 200.
200, yeah, and that's 160, yeah.
Yeah.
So we have 160 is equal to FDE. So what do these angles have to be? in isosceles triangles, these angles are the same.
Yeah. So
So what's one of them? If you know that the angles sum up to 180 in a triangle.
10.
10? Okay, so we know this small angle right next to here is 10. So how do we find this big angle? AFE.
3. So I mean 180 minus 10.
Yeah, because we know the straight angles
Oh,
with the
yeah.
supplementary adds 180, so we get a total of 170 degrees. And that's our answer, 60.
That was fast.
Light work.
Damn.
I don't know how I got stuck on 4 still. Problem 7. A school has 100 students and 5 teachers. In the first period, each student is taking one class and each teacher is taking one class. I said that wrong. Teaching one class. The enrollments in the classes are 15, 20, 25, and 5. Ooh, so let's group this. 15, 20, 25, 5. Yeah?
What?
And there's 5 teachers for each of these classes. You see that? Teacher 1, teacher 2, teacher 3, teacher. I'll call them different. Teacher A, B, C, D, and E. Yeah?
Yeah.
And they teach these classes. Let S be the average value obtained if a student was picked at random and the number of students in their class, including the student, is noted.
Wait, okay, I don't really understand that.
Yeah, what does... Okay, I think we need to read this. Let T be the average value obtained if a teacher is picked at random and the number of students in their class is noted. Okay? So that means you can choose one of these at random,
Yeah, but
and T is going to be the number of students they have. So what's the average you get? Okay, we don't have to worry about that yet.
Plus 20 plus 20 plus 5 plus 5.
But we know that it's going to be, because you have a 1/5 chance equal of picking every teacher, right?
Yeah.
So what's the chance that you get 50? 1/5 times 50. Yeah,
Oh, yeah.
don't worry about it. And then you get 1/5 times 20, then 1/5 times 20, and then 1/5 times 5 times 1/5 times 5. So you can factor out the 1/5. Yeah, you see what I did there? Take out the 1/5 from all of them, and then you get 1/5 inside 15 plus 20 plus 20 plus 5 plus 5 for the average score of all of them. But you know that this is just sums to 100, right?
Yeah.
So what's 1/5 of 100?
20.
Yeah, so T equals 20.
Yeah.
Let S be the average value obtained if a student was picked at random and the number of students in their class, including the student, is noted. So now we're having like weird probabilities. We have 50 over 100. That's the chance of picking a student from this class.
Yeah.
Times 50. And then for this one, we have 20 over 100 times 20. And then we have 20 over 100 times 20 again for the next class. 5 over 100 times 5. And then finally 5 over 100 times 5. And then we have to add all of these up. 1/2 times 20, or 1/2 times 50. What is that?
25.
2 over 100 times 20. What is that?
2 over 100. What?
1/5 times 20.
Yeah.
What is that?
4.
We have 4 again. 5 over 100 times 5. What is that? Do you know what that is?
5.
You can think about it as 20.
25 100s.
Yeah, well, what's 25 100s?
0.4.
No.
Oh.
0.25.
Oh, 25.
And
My bad.
then finally we have 0.25 again.
Yes.
That work. And we just have to add all of these.
Oh,
So then we get 25 plus 4 plus 4. That's 25 plus 8. What's that? 33?
Exactly.
Okay, and then we get 0.5 for 0.25 plus 0.25. And then we get 33.5. It's asking us for T minus S. So T was 20 minus S is 33.5 is what?
Negative 13.5.
Is that an answer choice? Yes, it is. Like what? 7B.
God. I can't believe it.
Also, my little brother is doing math Olympiad, so this is good practice for him, right? Right?
This is so good practice.
Okay.
I'm definitely gonna do his math Olympiads.
Bro. Let n be the least common multiple of all the integers 10 through 30 inclusive. Ooh, do you know what least common multiple means? Okay, you don't. I'm just kidding, you do.
Oh, these common multiple.
Let
Yeah.
n be the least common multiple of m. 30 blah, 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 blah. What is the value of n over m? Ooh, that's brutal. So don't worry about the value of n over m first, because you know that you need to find n and m to find this.
Exactly.
And you need m to find n, so let's just focus on finding m first.
You need M to find n.
What is the least common multiple of all the integers? It's not going to be 2, and it can't be even because we have odd numbers.
True that.
Least common multiple. Oh, that's the one where you multiply.
Oh my god.
Oh, that's so brutal. Okay, we have to find all the primes. So we got 11. What's the next prime? 13.
Yeah.
What's the next prime?
17. 23.
23.
29? Maybe?
29.
37?
31.
Oh, 31. 37. Wait.
33. Oh no. 37. Yeah.
This is very fun.
I think we missed one here. 19.
Oh, my bad.
And then I think that's it. Yeah.
Yeah.
Oh, we weren't even supposed to go past 30. Okay. So, we're also gonna have to count before that. So, 2, 3, 5, 7. Yeah.
Is legit?
Did I get all those?
Yeah.
Okay, we good. We good. And then least common multiple, you multiply all of those together.
Yeah.
But can we actually do that without a calculator?
No.
So let's just say m equals 2 times 3 times blah 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 times 29. Okay.
Yeah, exactly.
Da-da-da. Times 29, because we can't possibly solve that right now. And then let n be the least common multiple of this added to some extra numbers. Yeah. So you know what to do there. Find more primes.
Oh.
37.
37, 40.
No, I think it's just 37. Am I right?
Oh, yeah.
So what's the value of n over m? Well, you just divide m, which is that big number, 2 times 3 times da da da, times 29. But n also has the addition of 37. Yeah.
Yeah. Oh, yeah, what you mean.
So we gotta multiply 37 to m to find the new common multiple. So we got n equals m times 37 over m. How do we find that?
Calculator.
No. Wow, you can just
Oh
cancel
my
the m's.
god!
And then we get 8c 37. Seems legit?
Very legit.
Okay.
Whoa!
It was 37? C, 8c.
Wait, that's cool.
That is cool, yeah.
Wait, oh!
Okay, next question. A right rectangular prism. Do you know what that means?
Definitely.
Let me draw it.
It's just like a rectangular prism.
Well, you got different kinds of rectangular prisms, right? This one's a right rectangular prism. Oh, let me draw a better picture. Right means if you take a cross section, it's gonna be right above the other cross sections.
Huh?
Yeah, don't worry about it. Just it looks like that. It looks like a box.
It looks like a box.
Okay, that's all you know. Whose surface area and volume are numerically equal has edge lengths log base 2 of x, log base 3 of x, and log base 4 of x. What is x? Okay, so you're doomed because you don't know how to calculate that.
What is log?
What is log? That's a good question.
Is it a question?
Is it question mark? What is x? Okay, so let's do this. Surface area. How do I calculate surface area of this?
You just get.
I'll assign variables first because that's important. Length is equal to what? Let's just say length equals log base 2x. Width equals log base 3x. And height equals log base 4x. Yeah. Surface area is what? It's gonna be 2 times length width plus width height.
Yeah.
Plus length height.
Length height, yeah.
Does that make sense?
Yeah.
How'd I get the 2?
Because there's 2 sides.
Ooh, okay. And volume is equal to length width height. Seems legit.
This is really legit.
So we're saying that log base 2x times log base 3x times log base 4x is equal to twice the product of each pair between those 3.
That makes sense.
Now what do we do? What is x? Okay, you probably don't know how to continue here.
What does that mean?
You don't even know what log is.
What is log?
Algebra 2. You're almost there.
Almost.
How much percent you did today, by the way?
Definitely 7.
Oh, jeez. You better be. Better be. How much time we got? 40 minutes. I want to do this. I forgot logs. Oh, but if I don't do this, we're doomed, bro. We need to get at least 12 problems.
If we don't?
We're doomed when we're not gonna meet the cutoff.
And
What is x? How do you multiply logs? I forget. If they have the same base, then you can do
multiply forehead. Just do multiply.
Okay, I'm gonna have to Google something here. I'm sorry.
Hey yo, cheater.
But this is gonna be change of base formula. I forgot this. I know it, and I'm gonna memorize this.
What do you memorize?
Log base d of a, log base d of b. Okay, so log 2 of x is gonna be log of x over log of 2. Ooh, we're getting somewhere. And log base 3 of x is going to be log of x over log of 3. Ooh.
Wait.
And log base 4 of x is what?
Log base x.
No.
Oh.
Log of x and log of
4.
Yeah. And it turns out that we can actually simplify this even further with logarithm product rule.
You forgot this again?
No, I didn't actually forget this. You just add them, but I'm trying to show you. So everything makes sense. This says log base a of xy is equal to log. Oh, wait, no, I'm lying. I'm trolling. You look at the exponent rule, power rule. Log base a x to the p equals p log base a. Oh, wait, I'm trolling.
What's he doing?
I'm trolling. Oh, wait, no.
Was it change of base rule? Oh, wait, that's what we just did. Oops, my bad.
Wait, I'm actually super trolling. What the heck?
I think it's a product rule.
Okay, apparently you can't multiply logs together. So we just have log x cubed on the top and then log 2, log 3, and then log 4, and then we just hope everything works. Equals. And then on this side, we have 2 times log 2x log base 3x is going to be log x squared, yeah. Let me put that in parentheses. Log x squared in parentheses. Over what? Log 2 log 3? Log 3.
I have very much idea what's happening.
Don't worry about it. I'm just using the change of base formula again.
Again.
Squared over log 3 log 4 log x squared over log 2 log 3, or log 4. But since these don't have common denominators, what do we do? How do you get these to have common denominators?
We.
First of all, what should the common denominator be? This denominator is log 2, and this one's log 3. Actually, I'll just tell you, because it's kind of hard. The common denominator should be that, because that's their lowest, or their least common multiple.
Okay, makes.
So this is going to be log 4 on the bottom here. But then what do we have to do to the top? Log 4.
Yeah.
And then this is going to be log 2. And this is going to be log 3.
3.
So in the end, we end up with 2 in parentheses log x squared. I'll just factor that out. Times log 2 plus log 3 plus log 4 over that one thing we got. Log 2, log 3, log 4 on the bottom. But this is about to look a lot better. I was about to say log a lot better. Haha. Because we know that this expression here, let me just drag it over with my Apple Pen. Technically, you can't do this either. What did I just do?
I think you broke something.
I'm just going to drag this over. You can't do this in real life.
Why?
Because it's digital. We're actually just going to multiply both sides by what?
That.
This weird expression here.
Yes.
I'm going to use colored pen. That's cheating as well. Don't do this.
What?
So now we have log. Oh, what is this?
A lot of things you're doing is cheating, huh?
Don't worry about it. Log x cubed equals 2 log x squared times log 2 log 4. Do you see what we do now?
You're a genius.
You see what we do? You see what we do here?
No.
Watch this. This is a cube. This is squared. These are the same terms. I'll cancel again.
Wait.
That cancels to a 1, right?
Yeah.
If I divide both sides by the square. So now I finally have log x equals 2 times log of 2 plus log of 3 plus log of 4. But we're not done yet. Look at that. What's log base a of x plus log base a of y? Just read that.
Log base a times xy.
So this is going to be actually log of 2 times 3 times 4.
Yo, you're a genius.
Log of x equals 2 times log of what's 2 times 3 times 4? Quick math.
24.
24. We're going somewhere with this.
People like, what's happening?
So you see what we did there?
Yes, I see.
宝宝不行了，8点半
Bruh.
了。
Finally, I'm about to perform like this maneuver here. This is a crazy time maneuver, okay? I don't want logs because look, none of these answer choice have logs in them. You see that? So instead, what I'm gonna do is I'm gonna raise both sides to the respective powers of 10.
Make as big as senses.
Log 24. And I'm just gonna do like a little pit maneuver here. We know that this is times 2, right? So I'm gonna actually toss that on the top here. What's 10 to the log of x? We know that's x because I just know that. Equals 10 to the log of 24. That's just 24 squared. Then what's 24 squared?
24 squared 6 1. Quick maths.
6, 7, 5. 576, and that is an answer. So 90. Light work.
Ah.
That wasn't too bad, right? Even though you don't know what logs are.
Even though I don't
Because
know
I
what you
cheated.
did.
Okay, finally. 10. This one looks like a big booty cheek. Let's go.
Then don't do it for
The
him.
base 9 representation of the number n is 27 million. What is the remainder when n is divided by 5?
What's base 9?
Usually in base 10,
Base 9.
we have 111 equals 1 times 10 to the 0 plus 1 times 10 to the 1 plus 1 times 10 to the 2, right?
Yeah.
That's base 10. But in base 9, this number here actually equals 1 times 9 to the 1, and 1 times 9 to the 2, and 1 times 9 to the 3. Sorry, 0, 1, 2. You see what I did there? So in this base 10, this will be equal to 101. Then this would actually be 9 plus 9, sorry, 1 plus 9 plus 81. Ooh, it's getting tough. This is actually equal to 91 instead. So for this 27 million number,
This is easy.
oh, that's not even million, jeez.
Million?
This is equal to 9 times 10 to, so this is equal to 2 plus 5 times 9 to the first. This is to the second, third, fourth, fifth. So it's 9, or sorry, 6 times 9 to the fifth.
Oh.
Yeah.
Yeah.
And then here we go, 6, 7, 8 plus 7 times 9 to the 8 plus 2 times 9 to the 9. And we're asking, if you add all of these, what is the remainder you get when you divide by 5?
Can you use a calculator on this?
Well, let's think about it. 2,
Oh, you divide by 5. I can
if
do
you
that.
divide 2 by 5, what's your remainder?
2.
So let's just keep that 2 there. If you divide 5 times 9 to the first by 5, what's your remainder?
9.
0.
No. Wait, what? Oh, yeah. My bad.
Now this one's a little bit trickier. 6 times 9 to the fifth. What's your remainder if you divide that by 5?
6 times 9 times 9 equals 18. 1 times 9 equals 7. 29 times 9 equals 6, 3, 6, 4.
Oh, we don't got to think about it like that, maybe.
Ouchie.
Let's see if there's a different way to think about this.
Calculator.
3. If you divide that by 5, your remainder is 3.
How you know that?
Yeah?
Oh, yeah.
Let's go next. 9. If you divide that, then it's 4. Yeah?
Yeah, exactly.
27. Then it's 2.
Yeah.
What's next? 81. Then it's 1.
Yeah.
And then what's next?
What are you trying
273. Yeah?
Yeah.
No? What's 81 times 3? 243.
240.
If you divide that, what's what? 3.
Yeah.
So notice there's a pattern here. Because if you go one more time, it's going to be 4. And we can check this on the calculator. I know this is true. I'm just going to check this for you because this is cool.
But you're cheating.
Well, I'm not. I already know this is true. Divided by 9 or divided by 5. What's your remainder?
Okay.
4. Yeah. So we just proved that 3 to the first divided by 5, you get a remainder of 3. 3 squared, or 3 to the second, yeah. I'm just going to delete that and say 3 to the second. You get a remainder of 4. 3 to the third, you get a remainder of 2 when you divide by 5.
Yeah.
3 to the fourth, you get a remainder of what? 1.
Uh-huh.
But look what happens after we go after 4. 3 to the fifth, you get a remainder of 3 again. See how that goes in a loop.
Can't believe it. Ding 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 ding.
That's crazy, right?
Yes. Really crazy.
So we know that 9 to the fifth is actually just equal to 3 squared to the fifth. Yeah. Which is equal to 3 to the 10th. But where would that fall? Where would 10 fall in this like thing? 6, 7, 8, 9, 10. Ooh, here you go, right there. So what would the remainder be?
4.
4. Yeah, that's 4. But then we multiply 4 by 6.
4 by 6, 24. You multiply 4 by 6. 56.
Wait, no, sorry. We would go one more because 6 also has a 3 in it, right? Yeah. So we'd actually go here. We'd land up in here, 2. But then if we multiply it by 2, that's 4 anyway. So like whatever, it's 4. So this gives us a remainder of 4.
Yeah.
And then we had 2 here. And let's see this one. 7 times 9 to the 8th. Oh my god. What would the remainder be? 9 to the 8th is 1. Yeah?
Yes.
Times 7 is what? 2? Because you have to divide that by 5 again. I hope that's right. I'm not even sure if that's right. And then 9 to the 9 is what? Remainder? 3. Times 2 is 6. So that's going to give us a remainder of 1. Yeah?
Yeah.
Hopefully this is right. I'm not completely sure. So I have 1 plus 4 plus 1 plus 2 plus 4 plus 0 plus 2 is what?
1 plus 2 plus what?
4 plus 0 plus 2. That gives us 3 plus 4 is 7 plus 2 is 9. Is that an answer? 9? Okay, that makes sense because if you divide it, you can't get a remainder bigger than 5. So if you add all the remainders together instead,
It's 4?
it's 4. 10e. Problem 11. Consider 2 concentric circles of radius 17 and 19.
That's concentric.
That's a good question. That just means they have the same center.
Oh.
So we got something that looks like this. Yeah?
Seems legit.
The larger circle has a chord, half of which lies inside the smaller circle. Please ask what a chord is.
What's a chord?
Good question. I'm glad you asked. It looks like this.
Yo.
What is the length of the chord in the larger circle?
Please ask what a chord is.
Well, this is a big problem. Well, we can assign some variables, okay? We know that half of the chord is inside the smaller circle, so we can call this, if the total length is 2x, yeah? Then this is going to be x in the middle, and these are going to be x over 2's. That makes sense, right?
Yeah.
We know that the radius is 17 here, so we get this like that, and then we get this like that. Yes?
Yeah.
No.
Also, by the way, the people watching definitely know what we're doing.
No, they don't.
Oh yeah.
Lol. I'm trolling them, bro. I'm not doing my work to show them. No, but I love you guys. I love you viewers. If you're listening to this, like, say something, bro, in the comments that shows that you're listening and you're cool. If you
Bro,
just happen to skip to this by accident, just say it anyways. It'll make me feel much better.
you just said that. No, no, okay.
Nah, bro, I love you guys. Okay, so we got 17 and 17 here. We got 19 and 19 here, but we do not know the angles. That's a big problem.
Oh, that does not look fun at all.
However,
What is Pythagorean
oh
theory of?
geez, how do you do this? Maybe.
Just split it in half. Forehead.
Okay, maybe we can do a little stunt here.
Uh,
No, no, we can't.
no, we can't.
Well, no, yes, we can. Yes, we can. No, we can't. No, we can't. Ah. Oh.
Wait,
What is the length of the chord? What is 2x? This is what's asking. 2x? Question mark?
well,
Well, we need some angles super bad, and I don't know how to get them.
okay, so that plus that equals 180. Oh my god.
Ah,
So,
but,
if you split that triangle in half,
um,
it's a triangle.
okay, I'm trying to see what you're saying.
Wait, if you split it in half, it's a half triangle. And then you can use. Wait.
1919. Wait, maybe I need to draw a better diagram here.
You do. Yo, positive circle, damn.
So it's gonna look something like this, maybe. No, it's not even close. Yeah, I can draw a circle like that.
Damn. Cheater.
G-Thord. I can draw a circle like that. Oops.
Oops.
But this is actually cheating. You can't actually draw circles like this in the actual test, but I'm using an iPad, so like,
Why can't you do that?
why not?
Why?
Exactly. And so we're just gonna draw the center again. And we're gonna
Yes.
draw a chord. This is gonna work. Okay, that looks pretty good.
Yeah.
Then we're gonna draw that out. That's 17s. Then we're gonna draw these out. Those are 19s. And we want to find what 2x is. How much time we got? 19 minutes? Let's just look through random problems.
Wait, okay. That has to be 90 degrees.
Why are you so hard? Why is this competition so hard?
Has to be 90 degrees. I just found something amazing. Oh, because that's an equilateral triangle. All of them are the same thing.
I'll just try problem 18. Oh, 17. Quadratics. I like that. For how many ordered pairs of b and c of positive integers does neither x squared plus b squared plus c equals 0 nor x squared plus cx plus b have two distinct real solutions? So it can have 1 or 0 solutions. And we know that since the sign of x squared is positive, because I told you this yesterday, if this is negative, it's definitely going to have 2, right?
Wait, what did you just say?
If the coefficient of this is positive and this is negative, so like so c is negative, then there's definitely going to be 2 solutions.
Yeah.
So we know that c has to also be positive.
Mm-hmm.
But that also means that b also has to be positive.
Mm-hmm.
So both c and b are positive. Or both b and c are positive.
What's the difference?
I don't know. And when we swap them, they still don't have 2 distinct real solutions. So I'm thinking here's what I'm thinking. We can just set both of the determinants or discriminants equal to 0. I have no idea why, but let's just guess. Discriminant of this one is b squared minus 4ac. And the discriminant of this one is equal to what? C squared minus 4ab. Yeah?
Mm-hmm.
Is that true? C squared minus 4ab. Okay. Now we can do a little jumble dumble.
You just said that.
And then solve for how many ordered pairs of B and C can we solve for. However, this seems futile as we have only 2 equations for a system of 3 variables. Well, A doesn't matter. Oh no, we know what A is. So this is just 4c equals c squared minus 4b. Ooh. Yeah.
What?
So b squared minus 4b plus 4b equals c squared plus 4c. For how many b and c is this true? Well,
Infinity.
I have no idea how to do this. But this is true for all b equals c. So there's something wrong with my assumption.
Means your assumption is wrong, forehead.
Let's just guess A, bro. 17A.
I'm gonna fail.
It's okay. Guessing's part of the game. We got 14 minutes left. Do a bit more guessing.
Good.
20 balls tossed independently in random 1 of 5 bins. Let P be the probability that some bins end up with 3 balls, another with 5 balls, and another with 3 balls. Okay, so we've got 5 factorial divided by 3 factorial over every bin ends up with 4 balls. Oh jeez, oh jeez, oh jeez. How many ways can that happen? One way. So that's not going to be right. But you're just listening to me ramble now. This is the 13-minute ramble. Oh my god, what? 5 factorial over 3 factorial is the number of ways to do this. over or goofied. I kind of goofy. Oh, my bad, my bad. That's 4 factorial to the. Okay, you can go sleep. Okay, 再见，再见。
不行，真的不可以让他睡了的。你过会儿要洗了哈，你看嘛，8点不睡。
I got 25. Why did I get 25? Let's think. Yeah, bro, I think this is doomed, honestly. Hmm. Well, 120, that's 525 squared. I don't know, man. What does 25 sound like? It sounds like 8, so let's just guess 18C. Let x be the real number greater than 1, at least such that sine x equals sine x squared. When is x rounded up to the closest integer? Ooh. Sine x equals sine x squared, where the arguments are in degrees. So we know sine x squared is, I forgot the power reduction formula. Sine of x times sine of x, which doesn't really help. I'm going for it. Power reduction formula for this. Sine. That's the wrong formula! Oh no. So you can't actually do that. Okay, maybe how about let's just do this in increments. Sine is greatest at 1. So how would you graph out 9 squared? That is so strange. We know this is gonna be like around here. Around 10 to 20. Sine x squared. I'm really not sure. Sine of 100 is gonna be bigger than sine of 10, obviously, if you look at the unit circle. Oh, maybe we can do like a little range check. Oh, but you want it to be equal. I see, I see. round it up to the closest integer. Would it be like sine of 9 equals sine of 81? No, that doesn't make sense. I see. It's like a clock problem almost. Let me think. So it's gonna be equal when sine of x is in the first quadrant and sine of x squared is in the second quadrant. Yes. And so we know that x is going to be equal to x squared minus 180. I think we're getting somewhere now. Because this is in, or 180 minus x squared equals x. Because that would be that one angle. So then x squared plus x minus 180 equals 0. And then now we just plug and chug quadratic formula. X equals negative b plus or minus square root of b squared, that's 1 minus 4 times a times c. So that's plus 4 times 180 all over 2. Oh, Jesus. And then we obviously don't want x to be negative values, so we want negative 1 plus square root of 4 times 180. What is that? 180 times 4 is just 18 times 4 is 32. 72 times 10, so 720 plus 1, 721 over 2. I don't know what square root of 721 is, and I'm sure there's some way you can check faster than a lot of ways, but I'm thinking it's a little under 30. Minus 1. So maybe let's just calculate 25 squared really quick. 25 squared. I should know this by heart. It's 625. So it's above 25 and it's under 30. Let's just say it's 27. I don't know. It's gonna round out. So let's just say 27 minus 1. That's 26 over 2. That's 13. Oh, they put two really close answers. That is so evil. Okay, we're calculating 27 squared right now because we have 4 minutes left. I'm doing this with a calculator. I'm cheating. I'm sorry. 27 squared equals 729. Ooh, that's really close. So square root of 721 is about 27, right? Okay, my guess was good. It's 26.8. So negative 1 plus 26.8 over 2 is going to be 12.9, which is 13. That was my guess. Let's go. Easy. 19. What is that? 19b? Okay. Let's get one more question. I think if we get one more question in and leave all of the rest blank, we can win. Even if I did a cheat a little bit. I'm not doing the circle question. It's big pain. Oh my god, what is this? What is the number of terms with rational coefficients among the 1001 terms in the expansion of this? So,
Excuse me，你要跟他讲一下。对不起，你有个明天做的功课哟。
okay.
就从那了哈。
We know that for square root of 3 to be rational, it has to be raised to some even power. And then we know for this, it has to be to some multiple of 3. So they're asking how many times does to the 1000. Why did they have to do this? That is evil. That is so evil. But you can't go wrong with choosing or guessing. So I'm gonna say it's probably gonna be. Oh, this is a big brain choice right here. I don't know why, but the rounded up just seems to work. It just seems to work. So let's see if we can get lucky. 12C. Trust me, it's gonna work. 12C.
Oh, I'm back.
It's not gonna be 500s. It's not gonna be 0, so it's gonna be one of these. Angle bisector of the acute angle formed at the origin of the Grasov line y equals x. Let's draw this out. And y equals 3x. Oh my god. Has line equation y equals kx. What is k? No, there's a way to do this with vectors and I forgot.
It's cheating.
Angle between vectors. Cos theta equals AB over, what does that mean? A dot B. Is that dot? Okay, there's scalar product over their magnitudes. Okay, I'm just gonna write this down real quick. A dot B, that's a dot product over their magnitudes. And let's just, how much? I have half a minute. If we assume this is square root of 2, and we assume this is square root of, no, this is doomed. We can assume this is vector 1, 1. And that this is vector. No, don't do this to me. Please, no. No, 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 no. Why you bully me?
I bet it's B.
I bet it's A. It just looks right. It smells right. I'm gonna go 13A.
It smells. Oh!
13A. Okay. It is time. I will add corrections. I'm gonna add a timestamp for the corrections later, but it is time to grade our problems. If you haven't been checking what I've been doing, oops, I didn't answer for 4. That's not an answer. I'm gonna cheat and answer right now. 3 or 9, let's just say 9. Why not?
Oh, wait a minute. Okay, I'm back.
Okay. So we're just gonna grade these answers we have here. Oops, not 9, sorry. E. And see if we would have made the cut in the real test.
For what?
Let's go. The AMC.
Huh?
Where do we go? Problem answers. So need to check the answer for 1C. Yes, we good. 1 is correct.
So good on God.
I'll put like a correct next to it. I'll say true, maybe.
Yes.
And then we have what, 2C? That's not good. This is very not good. Did I not say that? Why did I say 2E? Oh, this is still the first problem. My bad. Next, problem 2. 2E. Okay, we good. If you fail the first couple of questions, that's just embarrassing, honestly.
I would probably fail.
I've failed it multiple times and I felt so sad and disappointed in myself. 3B, we good. 4E. Okay, we good. I told you it was gonna be 9. Let me see the reason why. What? Congruent to A. Congruent to 5 plus A. Hence. What does this mean?
It means that the
That is
answer
a.
is 9.
You have to divide that by 11. Oh, that's tough.
Kind of genius, so. Now let's look at the video solution.
Honestly, I love this one. I just need to understand it. I'm gonna learn modular arithmetic. Trust me. Well, you know, I guessed right. My intuition was right. That counts for something. 5. B.
Good.
We good.
Oh my god!
6.
I'm gonna jinx you.
D. Huh? We good. 7B. Hey, I have a chance of winning this, bro. 7D.
Oh, B.
B. Did I say that? We good. Oh, you thought I was gonna get that wrong,
I
huh?
thought you said D.
The best. 8C.
Get this correct.
Ah! There's no way. It's 2? Where's 2 come from? Oh, you have to take these prime factors. That's brutal. Where does this extra 2 come from? Oh my god. 2 times 37? Where does that come from, bro? The greatest powers of the prime factors of the...
Because we have an extra power of 2.
Oh, because this is going to be 2 to the... That's 2 to the 5th. Oh, man, I was so close. Okay, but it's wrong, so I'm gonna have to mark it false. Damn, that's brutal. There goes my chance of winning. Nah, I don't got that much chance no more. This one's E. That one's... I could do that. That's light work, bro. 10. D. Did I do that? Modular arithmetic. I don't think this one's good. I think I got it wrong. 10D. Ah, that hurts. I need to learn this modular arithmetic thing, bro. Mr. Enthusiasm? Oh my god, this kid. Oh my god, this kid. He said I could win the AMC last year and I didn't. But thanks for trying to help me anyways. 12. Here we go. See? Hey, I guessed that shit too. W.
Just good at guessing, I guess.
I am though. Alright. Oh, W. Mr. Enthusiasm. I like it. W men's. Or woman's. But he says Mr. so men's. 13A. I have no idea what the reason is, but I got it right. Let's go!
So you need both of the questions at the end to be correct.
Oh my god, that is so brutal. What is the solution, bro?
Wait, did you guess this one?
Hmm?
Did you guess this one?
Yeah.
Like fully?
I just completely guessed it because I knew golden ratio, bro, equals 1 plus square root of 5 over 2. And I just saw it and I looked and I said, that's a good answer. And I got it right.
Because it's a golden ratio.
Because it's the golden ratio. If I took this test last year, bro, I would have performed. 17A, let's go. Oh my god, there's no way these dudes are actually doing this crap.
Well, just do the golden
Distance
ratio.
between a point and line, I forgot that formula ages ago.
Oops.
17, here we go. B. Ah. Okay, I actually guessed wrong. That's so sad.
Damn.
You get points off if you guess stupid answers. That's true though. I shouldn't have guessed that one. I don't know.
Doesn't matter. You don't get points off this time.
18E. Uh-oh. Uh-oh.
GG.
Oh no. Don't do that.
Okay.
19B. Come on, I have to get one of these right. Hey! Hey! Oh no, because I actually knew the solution to that. Okay, so 13B. Or sorry, no. What's that? 19B. We're on these. It's time to grade. It is time to grade.
1, 2, 3, 4.
Okay, if you refer back to the official rules, um, AMC Fall 12 problems, it says you will receive 6 points for each correct answer, 2.5 points for each problem left unanswered, 1.5. So let's just assume all of them are 1.5 if I didn't answer them, and 0 points for each incorrect answer. So what this means is, let's see how many correct answers we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 correct answers. That doesn't seem like enough. Will we get to multiply that by 6? How many did we get wrong? 1, 2, 3, 4. We get to multiply that by 0.
Damn.
And then that leaves us with 10 questions left unanswered, which we get to multiply by 1.5. So we get 66 plus 10 times 1.5 is 15. Is our total score
More.
of 81 points.
CGJ?
Oh, geez.
Is that good or bad?
I don't know. Let's see. AMC 12.
I think you
2021 Fall AMC 12A cutoff. This is the moment of truth. There's no way. Amy cutoff. 12A. 91 points.
I think you would have failed.
Oh my gosh. Oh my gosh. Okay, I failed. I failed by like a whole 10 points. Oh well. Yeah. And I guessed a lot of those, so this is doomed, bro. I'm not gonna go into the Amy. Oh my gosh, why me? I got lucky on a lot of them too. But okay, final score we got 81. And that's it for the video. I hope you enjoyed listening to me ramble and work with my little brother.
There you,
Who didn't go brush his teeth yet?
I did.
Oh. And I'll see you next time. Peace out.